This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
Okay, welcome. This episode of Software Engineering Radio, brought to you by IEEE Software, is an interview with Christof Ebert. He's a regular columnist with IEEE Software Magazine and has extensive experience in the software engineering in practice areas. Christof, would you please introduce yourself?
Hello, my name is Christof Ebert. I'm the Managing Director of Vector Consulting Services. We support clients around the world to sustainably improve product strategy, product development, and to manage organizational changes. Vector Consulting Services is part of the Vector Group, which has 1,100 employees worldwide and serves practically all continents. Prior to my current responsibility, I held a number of global management positions for 10 years at what is today Alcatel-Lucent. I'm serving on a number of advisory industry bodies and lecture at University of Stuttgart and some other universities. Over the past years, I've authored several best-selling books, including the most recent book, Global Software and IT, which is published by IEEE and Wiley. We will look in this web podcast on lean development, and we will look into how it applies to software and IT. Often, lean is associated with manufacturing. We will show what the principles are and how they apply in IT and software projects. And in doing this, we also refer to a recent issue of IEEE Software, where we looked into several case studies on applying lean principles to software and IT.
Okay, great. Okay, I think many of our listeners are probably very familiar with the topic of Agile in the area of software engineering, but maybe not quite so much with the topic of lean software development. Could you perhaps, especially for people that are familiar with Agile, how can you try to visualize how Agile and lean are related? Are they very similar? What are the different, what are the commonalities and variabilities between the topics of Agile and lean in the software space?
Lean has received currently a lot of attention because it nicely balances the need for value creation with the need also to empower people, to empower teams, and to move forward with innovative products. As such, lean development is a key principle to the advantage of companies which sometimes struggle in improving efficiency and at the same time not strangulating their R&D departments.
Okay, and is the would you say that Agile is very specific typically for very particular projects, and lean is a more holistic, more of a philosophy also, a sort of a, it's like Agile.
Well, maybe
lean?
Yes, I think it's relevant to see some distinguishing points. This is why I draw it a little bit black and white, looking Agile more to the development activities and lean development more to the how do different, let's say, projects, different components, different features interact. But on the other side, I don't want to be that much black and white with distinguishing the two techniques. As I just said, they enrich each other, they relate to each other. They certainly do not pose a kind of, it's either Agile or it's lean. And maybe in a moment we find some time to kind of define lean development and look to the key techniques, which is then easier to see. But for now, I see those techniques enrich each other. And when I said earlier, value creation is a common denominator. You can create value if you want, bottom up by looking how you're doing things and how you can do things better, such as how can you be more efficient in coding, how can you avoid a defect in the first place. And there's then something which is called test-driven development, which is an agile technique where you think before you write some code about how would you test that code, and in thinking about the verification before the instantiation, you already avoid a lot of defects. Now, this very technique put to the level of a product, such as would we need that feature for that market, or is it just an overhead, is what we call lean development. And this is where I would be very clear emphasizing that the two techniques enrich each other rather than it's one or the other.
Mm-hmm. Okay, thanks. Perhaps another area that we haven't gotten into yet is perhaps an area of the people and the importance of people. I think that's perhaps a question to you. Is that also another commonality between Agile and Lean, is the respect for people, the empowerment of the team working together, whereas in maybe some other types of development, people are more viewed as sort of interchangeable resources and so on. And I think that kind of feeling I don't understand with either Agile or Lean. Could you speak some to that? Because I know you have a lot of experience also in the people aspects.
Well, I think now it's the right time that I briefly sketch what are key elements of Lean. And then you will see that each of those, which I consider key, have their immediate sibling, if you want, brother or sister whatsoever in Agile. And I said one of the 5 which I typically distinguish, that's value creation, and I start with that one because it's giving us the right scope. And you're definitely right. A second one is people focus. So value is the perspective to the outside, which is what's the need of the customer who is eventually paying for the product. But the second one immediately is people and teams, and how can we empower teams to be in a better collaboration? How can they be more responsive to immediate questions? How can they work together in order to create the value? Then there's a third one, which is to eliminate waste, which is the dimension which I mentioned earlier, which you can see on the coding level as reducing the defects by applying intelligent techniques, or at the product level by avoiding that you have features which later on would increase complexity, in the sense of Fred Brooks, the accidental complexity, that is things which are not necessary, while you do not really bring any value. And that's principle number 3, to eliminate waste. Then a fourth one would be to optimize a value stream, that is to look to different tasks, how they relate to each other, and making those tasks more efficient, to, for instance, avoid that a designer has to wait for a colleague just because the work chunk is not ready. And if you put all these wait periods together, or if you have a lot of question and answers because people do not understand the specification, that would certainly be very inefficient. So for that angle, to optimize the value stream is a fourth principle. And the fifth and last of my enumerated list, this is to continuously improve. And again, this is a technique which is very key to any type of engineering, because if we would not learn in terms of technology, in terms of process, in terms of our own skills and competencies, we will not survive in industry. And we should never assume that we are perfect, neither our product, nor our technology, nor our processes, nor we as a person. And if we put those 5 together, value, people, empowerment, waste reduction or elimination, optimized value streams, and continuous improvement, this is what we call the key principles of lean development, already translated into software development. And as I said, each one of these 5 relates a little bit to Agile, and for that angle, they have a lot of commonality and would be distinguished just by the way you look at it. You look, as you say, you look at it more holistically. Then it's what we call lean development. If you look to it very specifically from a perspective, how can I do my individual feature coding in a better way, that would be then more related to Agile principles.
Okay, that makes a lot of sense. When we talk about the difference to, perhaps it'd be useful to talk about the difference also to lean in the area of production and manufacturing. In what sense is lean management in the development area different? I think there's perhaps more variability in the products. There's a lot more uncertainty, and so I think perhaps one has to apply lean in a slightly different way. I think Alistair Coburn talks a lot about having the decisions and information is what flows through the product. Perhaps that's a useful view. So what differences do you see between lean as it is applied in manufacturing and in these early phases like the development areas?
Yes, I think it's important to look to this difference because often I see a kind of reaction by software practitioners who would say, well, lean I have heard a lot about, like Toyota production system, etc. Isn't that only for car production? And obviously, without any doubt, this is where the word comes from. And historically, there was a link to production, and only after a while, a link to engineering has been built. And what I want to emphasize is that we should be clear that lean production with its methods, also having been a kind of trigger, is certainly not what we now look in lean software development. There can be a lot of parallels being seen. I mean, to eliminate or avoid waste, that is something which you see both in production and in software development. Rework, empowerment of people, obviously they go all in parallel. However, we kind of confuse people if you would take too much production-oriented example. And this is sometimes a trap which I see if people explain lean development, that they got stuck in these commonalities rather than saying, well, what is specific to software development? And you're definitely right that in software there's a lot of differences. One of them, as you mentioned, with what you consider information flow or variability, or the life cycle of software, which is all so much different from a product which is manufactured and produced maybe by robots, that we should not look too much to the commonalities, except that there is a historic point where lean software development branched off lean production. But this is so long ago, and nobody would today look too much back to those roots. But what we should certainly do, and this is the other viewpoint, as practitioners, we should always be aware what's going on in other engineering disciplines and what can we learn by looking into other industries. This is my other criticism. I mean, if one person would say, well, lean production is not for me, I'm in software, that's fair because the product is different. On the other side, as a software engineer, I would expect that that person is open in order to also get new stimulus, like the stimulus we received in architecture from civil engineering. And I saw software architecture growing over the past 15 years. Initially, the stimulus for this push of software architecture that was coming from civil engineering and from civil architecting. And this is something where I'm also a bit careful, specifically when I teach it in school, that people are not too much, this is my discipline and I'm not looking left and right. I think specifically here in IEEE software, we have a quite strong background in also trying to learn from the application domains where software and IT is actually deployed. And this is why I'm often interested, how do other engineering disciplines practice lean, and what can we learn from it in order to evolve lean software development. And let's just take one example to be more clear. When we have been talking earlier about the rework as an example, which applies both in Agile as well as lean software development, it's something which is unnecessary. But now, how do we distinguish necessary from unnecessary? There are different techniques, and one technique which helps us very much has been coined by Al Davis many years ago when looking to requirements. He said we have to apply a principle called triage in order to distinguish, based on a very few essential questions, what's the contribution of that specific feature to the overall product. Now, if we look, where does this triage come from? Well, it comes from medical. It's a key principle if a doctor arrives as an emergency case where a couple of people are lying around, that he has, as one doctor, not much chance to help 10 persons in parallel. He applies triage to find out where would his help add most value at the very moment. And these kind of principle and insights would not really ripple into our industry and fertilize our industry if we don't have this background from other disciplines.
Yes, that's a good point. So we can use that to prioritize and so on. Yeah. So I think that's very true, that we can take the best out of the Agile space, take the best out of the lean manufacturing areas, and grow your own that fits your own organization and its needs as appropriate. Yes. Okay, that makes a lot of sense. Maybe we should go through your various points. Maybe let's start with the value creation, which I think has a lot also to do with the requirements engineering area that you're also very, very active in. What is a good balance there? To sometimes one says one should do a lot of upfront design, make sure you do it right the first time. You hear sometimes out of the lean space, but on the other hand, you sometimes also hear the term decide at the last possible moment. So what's your take on that? How much do you do upfront, and how much do you try to delay?
Yeah, I mean, both is true, and I think clearly we should understand both principles, not as a kind of contradiction, but as enriching each other. What we should definitely avoid is that we exaggerate on the analysis part, which is what we call paralysis by analysis, because that slows down very much, and we should be aware that we can never specify to the last detail. So what is the key difference here is to understand in the beginning what are those requirements which create most value for whoever is the user or customer, and that can be an entire market share, or in a new product it can be a new distinguishing feature, while on the other side also keep flexibility, be it now for the individual product, because some of the requirements are just uncertain, as is almost the rule in specifically software and IT projects, or be it to preserve a sound variability for the evolution of our product, because maybe we want to go into different markets, maybe we want to have a low and a high cost or price version of our product. In other words, when we start with a product, or when we start to elicit requirements, the key question in the beginning is, are these requirements valuable? Now, obviously, if you ask the question that blunt, any customer would always say yes, of course, and he would probably be the wrong customer to say no. I mean, I just gave you a garbage can of things which we never use. So it has to be intelligently evaluated, for instance, looking from different viewpoints, looking from different profiles. These are all requirements techniques which are today very much used, but essentially just to do what I called earlier the triage, that is, identify those which have highest value, where somebody would pay most for. And I give you a simple example, which I sometimes apply if people would just always come back and say, well, our requirements are all high priority, we need all of that, and we need it now, and you know, these kind of things, that you have a list of, let's say, 100 requirements, and you sit in front of a couple of people, product people whatsoever, and then you just give them $100 in their hands, and you would ask them, so now you buy your features, and they know there are a couple of other people in the room who would also buy features, so they have to split their investment intelligently. Also, it's a game. It turns out to be very effective because they strategically put money on certain content, and it gives you in almost all cases a 50-50 split, which is rather clear of what are those requirements which have a value and which are those which are, if you want, nice to have. And this is one of the key principles of value. Now, another one which relates very much to the topic which we called eliminate waste is to also understand which of the requirements, which of the features have a big impact on architecture. And those obviously also have to be understood in the beginning, because if there's a big architecture impact, we better do it right in the beginning. Good example are the so-called quality attributes, like security, usability, etc., which should be evaluated very well in the beginning, because doing those things late means to lose a lot of time and to have a lot of rework.
Yes, that's an excellent point. I really appreciate whenever you talk about this area, you always emphasize that it's not just always what the customer says that they need, but you really need to fully understand what the customer really wants, and really, you know, dig deep enough to know that the customer really wants these things like performance and scalability and so on, and not just what they say, but what they truly need, and to address that. Yes, that's a good point.
Yeah, it needs a lot of soft skills. That's my experience with this whole topic of deciding in the beginning what are we going to do and how relevant it is, because it's not a blunt negotiation where you say, well, you know, you give me that requirement, and if you do it fast, I don't need that other requirement. I mean, this is not what I want to tell, but rather to, together with the customer, evolve, develop the requirements. And in fact, it's a quite interesting evolution in the requirements engineering and in value creation that some 10 years ago we were speaking about requirements collection or gathering requirements until the community realized there's nothing to gather. I mean, as soon as you start to collect requirements, you're already on the wrong track. What is much more important is to develop requirements, to elicit, to find out together with customers, together with people who really understand the market, who really understand the needs in the future, what would be the right requirements. And if you only collect things because others have done it already in their products, you're always behind. So this was a key learning over the past decade. And again, this is something which equally applies to Agile development as well as to lean development, just looking from different perspectives.
Okay. Perhaps another aspect associated with your first topic of value creation, perhaps one can also interpret value also as the knowledge that you get in some of these cases. I know, for example, there's the topic of set-based decision making, which comes, I think, from the lean manufacturing area, where you keep your options open, and you allow various alternatives to be alive a longer period of time. It sort of is frustrating sometimes for the managers. A typical macho manager wants to say, just bang his fist on the table and say, just do it, just decide which way you're going to go and do it and bring the project to the end. But perhaps one of the things that one can do in Lean is also to try to keep your options open, and because even if you throw one of those away, it's not waste because it brings you value, right? It's not the artifact itself, but that knowledge itself is valuable, I think.
That's definitely true, and actually you mentioned two very valid points. The one is that we continuously learn, and even in evaluating different designs or making an explicit architecture decision or explicit decision which part of the system to test more thoroughly than other parts, we continuously, if you, as you say, throw away something and keep others. And I recall in one of the very big learnings also in the past 10, 15 years was that we face a lot of decisions under uncertainty. That holds, by the way, for all engineering disciplines, but we're talking about software and IT. So we need techniques to prepare such decisions, and we have later on also to efficiently execute the decisions. That's another story. But a key element which is often overlooked is that in order to decide, we need alternatives. And comparing and evaluating these alternatives based on criteria is something which is even today not so often done. Often we just shoot out of the hip. We have a gut feeling. Maybe we put 3-4 different alternatives aside each other, but finally we jump very fast into one without having really clear evaluation criteria. And this is bad because we often have conflicting targets. Take architecture decision where you want to have a very efficient system at the same time with high security level, and you want to decide to which degree do you evaluate individual packages on a network, or can you cluster that doing on a bigger scale, which would be more performant but maybe later easier to break. These are all alternatives, and in evaluating the alternatives we learn, and that learning clearly is a value creation even if we would not deliver the one or the other feature in the end. The other aspect which I consider equally relevant is that at the moment when we have options to decide, that we also evaluate when should they be decided, what's the timing. And I said earlier, sometimes it's good to do that early because it has a lot of side effect if done wrong with a lot of rework. Sometimes it's good to do it late, or, and this is more and more relevant, or even keep it open forever in a way, as we, for instance, do today variant design, that we keep some variation points where we can switch in a efficient way between different implementations, just to make sure that, as I said earlier, you have a low and a high price version of your product that you can, for instance, sell and upgrade by a remote switch, and not by a lot of variance coding and all these kind of anticipating decisions and planning the decision at the right moment is the second important learning when we think in terms of eliminating waste.
Okay, great. Maybe that's a good point to go over to your second principle, the people focus, because both of the things that you were just now talking about have to do with the learning and the experience. If you can't have that logical way to decide between the alternatives, and you really have to rely also more on the experience of the people. It makes sense to not view people as sort of resources that you can just plug in and plug out at will. I think in the lean area, I believe one tries to empower the team as much as possible and put a lot of value that they are well trained, and that you have more distributed intelligence and distributed decision making in the teams. I think that's a very important part of lean. Do you have experience in that area, or can you comment on that?
Yes, empowerment to me is one of the key success factors. And again, it's a principle which we practice in Lean, which we practice in Agile, which you find in many other management theories. For instance, if you see the evolution of Peter Drucker's work from the organization level to the individual level, you see this learning effect much earlier than anyone in software has practiced it. But you say very much in the beginning that still we often see very hierarchical decision making. What Lean means with the empowerment of teams is that in order that the team can take decisions and take the right decisions, you also have to give knowledge to the team. You have to give the team these skills so that they have an understanding of the background. And this is something which we often hesitate to really implement, because what it means, seen from a distance, is first of all that this team is doing things which are not really their business. I mean, they, for instance, have to understand the business of the customer. They have to understand relationship to other modules, components, etc. They have to understand feature interaction. They have to understand roadmaps, where each normal manager would say, why the heck should that team understand all these things?
Mm-hmm.
They should
I think
go
psychologically they also don't want to let go somehow, don't they?
Yeah, exactly. That's one of the reasons. And the other one is clearly that it's just considered additional effort, which somebody has to pay. On the other side, once you practice it really in, let's say, grown organization, you will realize that these teams are smart enough not to waste their energy on things which are entirely pointless, but they would ask questions where they know there could be impact. And I've often worked with teams on this evolution path from being more a directed team, which would get more or less an order of the day, as I call it, as we see it in military, for instance, where it certainly also makes some sense in some situations, but which is not at all really productive in software development, where you have so many uncertainties and unforeseen constraints that it's good that the team has a necessary background in order to decide. And this transition sometimes is a bigger challenge for the line managers as well as for the team. And you're definitely right. At the moment when the team gets these kind of, I call it in quotation, managerial skills, obviously they grow, while their line managers fear that they will have not anymore so much to do. But let's be clear, I mean, who are the companies, which are the companies which really have the steepest growth in competence and ultimately in value creation with a single product? These are typically start-up companies. And the reason for that is that each one in this team has a very profound understanding of content, environment, and business. And this is why they are so fast in creating new things. And what we need to establish is that these principles can grow independent of the company, be it a small or be it a very big multinational company. And it works. I've seen transitions into lean development with team empowerment in very big companies, such as companies with many thousand people working worldwide in engineering. And still, at the moment when you empower the teams and you let them in a certain scope move in that direction, you would see that the overall motivation was fast growing. And
I think it happens probably fairly quickly. Does it happen fairly quickly in your experience, that once the line manager sees that the team can make those decisions and make them correctly and effectively?
It depends on three factors. Yeah, there's three factors. One is certainly where do they come from, and if they have very strong line management principles, it's certainly taking more time because all the genes of engineers and managers are of the other dimension. Now, a second principle is the context of the work. I mean, if you have small projects which are rather individual or independent of each other, it's much easier to install team responsibility than if you consider a project with 200 plus people working on a single objective, as we often see in, let's say, avionics or automotive or medical or big IT projects. A third dimension, finally, is to which degree are the people and their environment really prepared to do it, because if the team would be hesitant because suddenly their responsibility is increasing. I mean, you have to face it. Empowerment is not just something which you receive as a present. It's also a thing which needs a clear focus that you have to deliver. And if the team or the group of people is not really so much interested into taking this responsibility, it might never succeed. I've seen such situations where even the genes were not there, the projects were rather isolated, but the people had somehow the attitude, we are paid as engineers, so we should not take a business decision, and this can really be the blocking factor in the end.
Mm-hmm. Yeah, I think it must be clear from the top management that one really is willing to take these risks and to encourage such activity, then make it clear that it's really a culture change, I guess. Yes. Mm-hmm. Okay.
Yeah, typically it helps to give the teams a small, let's say, responsibility change and iteratively let it grow. That's my success recipe here. Rather than saying, well, as of tomorrow you are fully empowered, because then it's really just a slogan. But if you gradually grow, considering these three factors which I mentioned earlier, typically it works out.
Okay. I think that was very useful about the team responsibility. Great. One of the topics that is most associated with the topic of lean is the waste, which was eliminating waste was one of the third topics that you had mentioned. Could you speak some to that, especially in the area of the different levels? Like if you have individual projects, or you could have whole organizations, because I think I like to say that maybe one person's waste is another man's treasure. You know, how do people really have the same understanding of what is waste in this context?
Yeah, I think to understand waste, that really means to look at the task at hand and look also to the product. This is why I started my list with value, because once you have understood what's value, it's easier to think, if you want, negatively in terms of what's waste. And you already mentioned earlier that we should also not be bluntly saying anything which is not immediately generating a feature which you can sell next day is waste. I mean, that would be a too shortcut perspective. Learning can be very helpful, and we discussed it earlier. So I think it's important, similar to what we just summarized about the team growing, that also the waste consideration is something which you learn gradually. Some type of waste is rather easy to understand. I mentioned earlier, clearly it's waste if a defect would be detected too late. Clearly it's waste if you implement a requirement which later on nobody wants. But okay, who gives you the criteria? And who would give you the, let's say, verification techniques to find all defects right away? If it was that easy, we probably wouldn't even need so much different methodology. But the real challenge is to learn on the way, based on product and business understanding, what is waste in what I'm currently doing, and maybe also occasionally get a step backwards to find out, as you just said, is what I'm doing currently maybe generating value for the next increment or for the next release, while for the immediate release it might be even a waste of time, or it might be an unnecessary circle. A key example which we often discuss in industry is to which degree should I document what I'm doing. There have been times where in Agile development techniques would be emphasized, which would say, well, the code is the documentation, which could be right if you have throwaway software, but sometimes this is not the case, and industrialized professional software, which has maybe also to follow certain standards, or which could be substance to some liability of the product needs to be well documented. Now, what does it mean to document code or to document architecture or to document a test strategy? This is certainly not something you learn in school, and this is what I mean to stepwise build these skills and then also get an understanding, because many people are in maintenance and then they are in new development, so they know over time how much documentation, what type of documentation is helpful in order to correct a defect in a previous release, and how much documentation would be the boundary where you would have rather overhead in your current product development. And this is what we call the good enough principle, which is a word where I'm quite careful, because I work very often in critical industries such as avionics or automotive or medical, where you are quite careful not to do things which later on would be considered wrong, or where you would have done not enough in order to have the right, say, safety and integrity levels. But it's clear that we should get experience in how much is necessary, how much is good enough for what is expected from my work as a professional engineer. And that depends on the industry, that depends on the user's expectation, and this is something which needs business sense and which needs also a profound engineering understanding, and this is what the teams will learn over time when they move into lean development.
Okay. Perhaps in the area of waste, we were talking before about requirements engineering, so things like overproduction and developing the wrong product very well, having features that the customer never really wanted. I guess those are some obvious ways of obvious things that are waste, but I think it really makes sense to use this term to consider lots of the things in the software engineering space. For example, again, with an example from the lean manufacturing, if you had some tooling device that has a cost associated with changing the tools that this hardware device has. This is, I think it's called a motion type waste, and it's similar in the software development. There's this waste associated with the context switching. And
right.
There's many people that are in, this one key expert is involved in 5 different projects, and the management often it neglects to consider this context switching of this person's brain is costing, 20% of the person's time or some such. I think it's useful to use that, I think, to call attention to the management of this not good situation.
Yeah, that's very true, that often we run into such situations and should be quite careful that if we develop and if we follow a certain say development path that of a product that we understand about features, that we understand about waste, and that we also understand from the perspective of requirements what's necessary, what's not necessary. And say historically, we have a lot of examples, and I will mention one just as a key point to summarize from our previous discussion, and we come to that tooling change. If we take Netscape browser, which had initially a huge market share of 90+% and declined in a few years against the Microsoft Explorer, that was something which you would never expect in internet age, that somebody could lose if he was once 1 or 2 years ahead. But the real deficiency in a Netscape product was an uncontrolled complexity growth without any architecture, without any product steering, without almost any documentation, not even a real project management. And these different factors together can ruin a product extremely fast, even if it's a market leader with 90+% market share. And these are the kind of stories which we should always keep in mind. I mean, we should learn from history in order to avoid that we repeat it. Now, what you say about changing tools and context switch, I think we know very much from our background in operating systems that in any context switch always means that we have to store something, that we have to take up new variables, which obviously needs time. And we have done a couple of studies, and there's also studies reported, specifically in psychology, that too much context switch, too much tasks which are pseudo-parallelized actually severely reduce productivity of a person and of a team. And the typical value which you should reach is 2 or 3 things which you do, let's say, pretty much in parallel, which helps to reduce a wait cycle, which could result from a single task which you do. On the other side, if you have 5, 6, or 7 coding projects in parallel, and continuously one from the other project calls you because he needs some interface agreement or he needs some explanation, then your context switches will not only kill your efficiency but will create a lot of defects. We have seen, for instance, in projects close to handover where a lot of these activities happen in parallel, that the defect rate under time pressure with different parallel tasks triples or gets much higher than the initial defect rate, just because with that stress almost no human being can really cope. Now, just to be clear, when we talk about parallel tasks, I mean engineering tasks. If you have an expert who would be, let's say, doing architecture and systems engineering activities, maybe this senior person would be able to cope with 4 or 5 such different products in parallel. But the broad experience from an individual perspective is that we should limit to 2 to 3 and not try to do too much in parallel. And this is again also a learning for organizations, which I often face, because they would say, well, I have that specialist and I need that specialist, as you said, in 5 projects. What should I do? I don't have the skills to replicate. And what I tell them is replicate. And it's very, very tough, not so much because of the individual engineer. I mean, they feel rather good and certainly empowered if they can learn more about a broader field. But their management, they think, I have this expert, why should I pay, if you want, the cost to ramp up 2, 3 others? While, again, it's a good Agile principle to work as a pair, because if one is sick, if one is absent, the other one is still knowledgeable about what his peer had been doing. And this is how I try to introduce the principles that it's common sense that we share our knowledge, it's common sense that we help each other, and it's common sense that we do not have that single specialist who we cannot really replace. And once this is understood, it's also easier to really thrive on empowerment.
Okay, yeah, that's fascinating. Yeah, great. I'd like to move on to the fourth topic that you had mentioned at the beginning, optimizing the value stream, or also the flow. This is a topic that I think is extremely important. We had Donald Reinertsen, who's an expert in the area of the flow topics and product management in the lean product management. And he gave a talk at Siemens about a year or so ago to many of our colleagues in the area of lean in development and engineering. And he has a very strong focus on queuing theory and focusing on not optimizing the capacity utilization of the people, these resources in the process, but instead to focus on the workflow and to focus on the throughput of the whole system. And it has some maybe connotations, context to the traffic jams that we have sometimes on the German Autobahn, right? If there's too many people, if you're trying to optimize these individual capacity utilization, and you can really get this huge traffic jam and nobody goes anywhere. So I think optimizing the flow is perhaps even an easier thing to control than budgets and schedule. I think it probably makes sense to have more of the knowledge on this queuing theory topics, which I think are probably also well known in the lean manufacturing area, but software people don't seem to know them very, very much.
Yes, in a nutshell, what is behind is that often, specifically if you have fragmented teams and organizations and tasks, somebody would do something, pass it on, and you have not only the previously discussed context switches, but you also have a lot of weight. You have a lot of say tasks which, as you say correctly, queue up. Somewhere you would have bottleneck situations like the before mentioned specialist, or because some resources such as a given infrastructure and testing is not available. I had recently worked with a client who need a rather big amount of very specific test environment, and one of their key bottlenecks was to get into this test lab and then really efficiently do test. Now, if you have too much, if you want incremental builds, for their context, it would not really work because they have an extremely expensive test environment. So they try to apply queuing more from the perspective of how can they most efficiently use their test infrastructure. So queuing and the value stream analysis, as we call it, is very important. The history is indeed traffic analysis, mostly in telecommunications, and it applies, as you say, also for traffic in all other sense. But a good exercise is actually just to sit down and draw a picture together with different functions in the project or in a product development and see what are the interfaces, how often are things passed back and forth. And the initial picture always looks very, very crowded with a lot of small activities. And what then has to be understood is how can you cluster certain activities like the empowered teams? How can interfaces be reduced? How can bottlenecks be reduced with different mechanisms such as like replicating some competence or infrastructure, or maybe outsourcing some activity, whatever. I mean, there are different ways to approach it. But the biggest eye-opener which I know in this whole picture of value stream analysis is always the first time when you have this picture ready. Often we just do it with post-it notes on a whiteboard and show it to the team once it is finished, because often they only know their own, let's say, environment. Yes. And they would suddenly say, well, we thought it the whole time, but we never really looked at it that way. And even if you later on would not really be able to, let's say, have one team with 5 persons who would do anything end-to-end, because that could also be inefficient, reducing certain interfaces, looking to where did we have in the recent project a lot of back and forth of activities, like insufficient requirements, which had to be reworked 5 or 10 times, or a bit further on if you have a project organization which is very much functional, but not so much in terms of end-to-end perspective of what's the product which we deliver. All these could then generate very useful discussions in the teams. How could this stream of activities be simplified? And this is a very helpful exercise.
Mm-hmm. Do you think that maybe part of the benefit of that approach is even just getting those people all together in one room and in front of a big wall full of Post-its and discussing that in person, to meet and to understand these people that that maybe the requirements engineering people don't ever meet the testers in person and to discuss
right
jointly?
Yeah, it helps to look to the right if you want slices of that whole picture. What certainly makes no sense is if you have a rather big team who try to draw the picture themselves. First, they typically don't have the technologies or methods how to draw such a picture, and second, they would focus very much on what they know and only guess. Now, what we often do is that we sit together with, say, smaller teams and sometimes individuals, and stepwise generate that picture. Mm-hmm. Then it's, as I say, the eye-opener to bring in these teams that just look at it and discuss it and related to their own experiences. And then if you want, draw some circles with red color around certain hotspots, and then give a team, for instance, or give two teams, like the requirements engineer and the tester, a certain hotspot, and say, look, here we have too much iteration, which are rather long and very costly, because in test you find out that a specification was wrong or something was missing. Why don't you do a review of the requirement for testability? Which, by the way, to my experience over many years, is one of the most effective and productive review and inspection techniques along the whole software development cycle. And suddenly they would better understand how do I have to document my requirements back, while the tester would probably much earlier understand what's the real purpose of that system. And in doing this kind of hotspot improvements, you stepwise move forward.
Okay. Okay. So, do you have some examples of cases that have been able to fairly easily take on these approaches that we've been talking about, or do you have recommendations on what first steps are for people that are interested in pursuing this further?
You now talk about all these 5 principles, or you talk about the value stream analysis?
Overall.
Overall. Well, in the meantime, we have a variety of examples, and I think, as a word of caution, we should not expect that Lean is something which has 10 principles or so and so many clearly defined techniques which you do. In fact, I even have seen, just to stick to our previous example, one company where they completely ejected on queuing to a level which was so theoretical. I mean, they applied real queuing equations that it was pointless, because you could not anymore really find out what to do different. This is why I said it's easier to have the picture and then look to hotspots and then use common sense in order to improve those. Yeah, there are a couple of very good examples where over time companies had introduced it. And I think since we mentioned earlier this IEEE special issue, it could be quite interesting just to look to this issue September-October 2012, where a couple of case studies have been presented. And one which I like very much is one coming from medical device development at Siemens, where a group of people have looked into a set of different Lean and Agile principles, such as feature prioritization, such as incremental development, etc. And they have shown that an intelligent mix or blend, or whatever you call it, of certain principles, together with the right education and competence management, only from a requirements perspective, yielded a 30% efficiency improvement in that specific platform development environment. Or another one which we have been looking was an empirical study which had been done on the effect of Kanban and Scrum in different companies, small and medium-sized companies. And again, independent of the industry, there were different industries, there was a clear experience that specifically what we just discussed in terms of waste and value stream, that these principles got a lot of value in the companies which were doing it. In other words, there is today already a set of good examples from which we can learn, case studies such as mentioned from IEEE software special issue, but also a lot of others. I recall when we received the papers of that special issue, I think we received 23 papers. So you see there is today already a lot of knowledge around. On the other side, I know also from my own background there is an equal amount of companies that try and fail because they underestimate the emphasis on change management. I mean, we talked a lot about change during these different introduction cycles, and if you overload a team, you can end up like in a Dilbert cartoon where the boss would also say, well, as of tomorrow you're empowered. So what? I mean, that's not enough. And this is why change management is also something to be seen as very critical success factor.
One of the big benefits, perhaps, of Lean is that it makes those cycles probably so short, so that you really have a chance, right? You have these very quick feedback cycles. You can learn very, very quickly, right? We've had these traditional waterfall projects that went for 2 years, and by the time you learn something, the business has totally changed. And then we had Agile and iterative processes where the feedback loops were much smaller. And I think with Lean, perhaps it's a good closing note. I think perhaps that the ability to learn quickly and to adapt, survival of the fittest, like Darwin, is perhaps that's one of the reasons also perhaps that it's more popular, that there's more possibilities to learn and learn also from failure and the successes that you have.
Right. A key principle of continuous improvement is that you really apply it continuously. And again, if we look, for instance, to Scrum, if you have these daily stand-up meetings where one key element is just that you are able to share some experience, and you can do that in a small and you can do that in a bigger context. And I think it's very important that you step back, let's say every evening or every Friday or so, and see, okay, what can I learn? What can we learn as a team from what we have achieved, and where we maybe were not as good as we had hoped or expected.
Mm-hmm. That's nice. Okay. Well, it's been a very fascinating conversation with you, Christof. I really appreciate your insights into this topic. I think it was very interesting, and I think hope that our listeners will also find pieces that they can apply in their practical work. So
yes,
thank you
and
very
I
much.
think it's always good if they would, when they have looked into some of the materials which we refer to, simply use also contacts sent in email or whatsoever. I mean, the contacts are always mentioned, IEEE software, and they would certainly get into a rich arena of expertise to draw benefits from.
Right, and perhaps write articles about them in the future.
Absolutely, so we can continuously learn from each other.
There you go. Okay, well, thank you very much. Okay.
Thank you.
Goodbye.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To support us, you can advertise SE Radio by clicking the Dig, Reddit, Delicious, or /dot buttons on the site, or by talking about us on Facebook, Twitter, or your own blog. If you have feedback specific to an episode, please use the commenting feature on the site so that other listeners can respond to your comments as well. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Please see the website for details. Thanks again for your support.